All right, here's some notes on electron configuration. Let's start off by just discussing some review of electron configuration. We know that there are large energy levels, and again, these are what we're going to be doing is discussing places where we can probably find electrons. And energy levels are 1 through 7, designated by the letter N. And I'm not going to get too much into quantum numbers here, just a little bit. And then inside energy levels, we have sublevels. And there are 4 sublevels, S, P, D, and F. And then inside sublevels, we have orbitals. And each orbital can hold 2 electrons, okay? So, with energy levels, we have sublevels, and sublevels, we have orbitals, and each orbital can hold 2 electrons. So let's discuss how many sublevels are in each energy level and how many orbitals are in each sublevel. So, let's do this. If you have energy level 1, you can only have the sublevel S. If you have energy level 2, you can have S and P. Notice there are 2 here for the number 2. Energy level 3 can hold S, P, and D. Of course, 3 sublevels. Energy level 4 can hold S, P, D, and F. And it starts to repeat here, S, P, D, F, and 6 is the same. Okay? So that's at least the breakdown of sublevels per energy level. Now, each sublevel can hold a certain number of orbitals. S can hold 1 orbital, P can hold 3 orbitals, D can hold 5 orbitals, and F can hold 7 orbitals. Okay? Now, if there are 2 electrons per orbital, as I mentioned on the previous slide, then I just basically multiply each number by 2 to figure out the maximum number of electrons that can fit in each sublevel. Whoops, that's 6 electrons. This is 10 electrons. And this is 14 maximum electrons. That means you can have less, too. You just can't have more than 2, 6, 10, or 14 per sublevel. So anyway, that's the breakdown there. Now, what we often see is how this all works out. So the way that I like to teach it is to read the periodic table and how to do electron configuration. So based on what we know so far, let's talk about electron configuration. Now this involves the numbers. Okay, 1s2, 2s2, p6, those kinds of things. Okay, so the way we're going to do this is we're actually going to look at the periodic table in order to make this thing work. Okay, this is the S block. So whenever I'm in the S block, that means that you are either currently filling the S block or the S block is already filled. This is the P block. So if I'm ever in there, we have the same situation. It's either filled or being filled. This is the D block. This is D block. I might as well label them. And down here is the F block, okay, which is one we'll probably largely ignore. Okay, so basically what this means is that if I'm going to do the electron configuration for oxygen, um, by the way, let me give you a generic electron configuration. Just a generic electron configuration, we typically write the elemental symbol here. That's not easy, just the elemental symbol. And we start off with energy level 1. And then 1 can hold an S. S can hold a maximum of 2 electrons. And then we have energy level 2. And 2 holds an S with 2 electrons and a P with 6 maximum electrons. And we talked about that the previous slide. And then we have energy level 3, which is 3s, and so on and so forth. Now it gets a little bit sketchy. Actually, we can go 3s or 3p6, and then finally, and then you would expect to have the D come next, but it doesn't. It actually jumps up to 4, and there's a reason for that, which we have to discuss a little bit later. Okay, so basically, let's do an electron configuration using the periodic table. All right, we're going to use these blocks in order to help us. And the way it works is this. Here, let me get rid of this marking. Okay, we're going to do oxygen. And if we're going to do the electron configuration for oxygen, that means that everything behind oxygen is filled. Okay? So I start off with energy level 1. And energy level 1 is the first row. Energy level 1, first row, okay, or first period. And that can only hold an S. And therefore, in the S block, I have 2 electrons. So far I've drawn 2 electrons. I got to draw 8. There's 8 right there. It's hard to read, but there's 8. But I got to draw 8 electrons. So once I'm done with 1s, then I'm going to go down to the second energy level, and then I fill the s block. That's 2. And then that's filled, so I got to go over here to the p block, and I'm going to fill this many electrons right here. So I'm in the 2p block, and I have 1, 2, 3, 4 electrons. So there's my electron configuration: 1s2, 2s2, p4. Let's do another. Okay. Let's do magnesium. With magnesium, which is right here, remember, everything up to this point is filled. So you start off with 1s. Now again, that's 1s is right here. So there's just 2 things in the s block, and it's kind of confusing because hydrogen and helium are separated. But you have 1s2, okay? And once you're done with that, and again, you're just reading this like a book, once you're done with this, then you have to go down to here. And then you have 2. This is s2. I'm still in the second period. I move over to here. Now I have 2p6. Okay, that's all filled. Then I move on, which means it brings me down to the third period, and I have 3s, and we have a 2. And then by 1, 2, I end up with the magnesium, and I'm done. So my configuration this time is 1s2, 2s2, 2p6, 3s2. Okay, electron configuration. Let's try one more before we get into anything that's a little bit tougher. Okay, let's try phosphorus. Okay, phosphorus is going to be 1s2. Here, let me clear it out. 1s2. So we start here with 1s2, and again, I got to get to this one right here. So I'm done with that one. I move down to the second period. So this is all filled. So that's 2s2. Then I move over to here because I'm just reading this like pages in a book. This is 2p6 because I'm in the p block. And back over to, so I keep reading. I move here to the third energy level, 3, and that's s2. And I move all the way over here now. I have 3p, 1, 2, 3. 3p3. Now, one thing that I haven't mentioned up to this point is I always have to have the correct number of electrons drawn. So phosphorus has 15 electrons. So do I have 15 here? 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 3 is 15. So this is good. I've drawn the correct electron configuration. Okay? Now, let me go back a slide here and let me talk to you about how the electron configuration gets all jacked up. All right, if here's my nucleus in the middle here, and here's my first energy level, it's pretty small. But then the second energy level gets a little bit bigger. So I'm going to draw it as a kind of a bigger donut here. So that gets a little bit bigger. And the third energy level gets even bigger than that. And so here it is, really big. Okay, so that's all the third energy level. Notice there's nothing in the middle here, nothing in the middle down here. And then I have the fourth energy level that is so big that it starts to overlap. So I actually see the 4s before I see the 3d. See, this is s, this is sp, this is spd, this is spd, f is all the way up here. So I actually see this overlapping business. So I actually see the 4s before I see the 3d. So this gets really strange. So what we want to do is come up with some rules on how to correctly interpret the periodic table. So if we go back to our periodic table here and get rid of this drawings, you'll notice that I've always been on the same period with the S in the P. In other words, if I'm on the third period, I have 3S. If I'm on the third period, I have 3P. If I'm on the fourth period, I have 4S. I have 4P. You get the idea. If I'm on the fifth period, 5S, 5D, 5P. You get the idea. But if I ever have the D, I have to take the period that I'm on minus 1. And if I ever have F, it's the period minus 2. We won't do too many of those, but you always go 2 behind the period. So the way this works is this. Okay, if we follow our rules that we just established, let's do vanadium. Okay, so we start off, let's do the whole complete configuration. We have 1s2 and then 2s2. So I just did this. Now I'm going to do this. 2p6. So I'm done. So move on. Now I'm on the 3s2. So I just did this. Move all the way over here. 3p6. So keep going. So now I'm in 4s2. Now I just hit the D block. And I have to cover 3 electrons. So D3. Now, however, D is always 1 behind the period that I'm on. Well, I'm on the 4th period. The 4th period is this whole row. But D is 4th minus 1, so it's 3D3. Okay? Let's make sure we have the correct number of electrons. I should have 23 electrons. So let's see, 10, 20. Yes, I have 23 electrons. If you count them all up, they're all there. Okay, let's do another one. Let's do zinc. Actually, let's do germanium right here. And let me clear out this slide out. So let's do germanium. So we have GE. So we have 1s2, which is this and this, 2s2, 2p6, 3s2, 3p6, 4s2. Now, where am I going to go here? I'm in the D block, so it's 1 behind. It's 4th period minus 1, which is 3. D. Now I got to get all the way over here. So this is all filled. The whole thing is filled. So 3D10. Now I'm back in the P block. And the P block is always equal to the period that I'm on. So is the S block. So I'm on the 4th period. So I'm back to 4P. And this is P1. This is P2. This is P3. This is P4, and so on. So this must be P2. Let's see here. For germanium, I should have 32 electrons. Let's see. Do I have 10, 20, 30, 32? We're good. Check. Okay. That's electron configuration. That's probably enough for now. We can do F block in class if you have questions about that. But basically, when you get down to here, you're going to be 6s2. You drop down here to 4f14. You come back up here to 5D. Okay, so F is 2 behind, D is 1 behind, and S and P are equal to the period that you're on. Okay, all right. I'm going to make a part 2 video, so look out for that. That's going to involve the rest of the notes here for this period, for this particular topic.